Hi everyone! In this video, I'm going to go through arithmetic series. An arithmetic series is basically the sum of the terms of an arithmetic sequence. So what I mean by this is if I have a very basic sequence, for example, say 1, 2, 3, 4, and 5, then firstly I know this is arithmetic because the difference between them is a constant. It increases by +1 each time. And so I know that this is an arithmetic sequence. And the arithmetic series would be 1 plus 2 plus 3 plus 4 plus 5. So it's basically just the sum of all the terms in that sequence. And this would give me 15. Okay, but what if I had the same sequence, but it went up till 100? Now for me to write out all the terms and then add them up or just even use a calculator is going to be very tiresome. So in order to find the sum of this sequence, we can use a formula. And this formula basically says S sub n equals, now S sub n means the sum till the nth term, so n is the number of terms, equals n over 2. So here I have 100 terms, so that's going to be 100 over 2, times 2 times u sub 1. U sub 1 is the first term, plus d, which is the common difference. Here the difference is 1, positive 1, times n minus 1. Okay, and this would be the formula I would use. And if I were to substitute the values for this particular sequence, it would be s. So the sum for the first 100 terms, that would be 100 over 2. My u sub 1, or the first term, is 1. So 2 times 1, plus my common difference is also 1, times n is 100, so 100 minus 1. And I could then solve this very easily. But just looking at this particular formula, you might say, well, this is kind of long, just doing this is going to take me time. We do have another formula, and I can only use this if I know both the first term and the last term of the sequence. So whenever we're doing the series, or whenever we're finding the sum, it needs to be a finite series. It cannot go on infinitely. So if I just had this without an ending point, so say I just had 1, 2, 3, 4, 5, dot, 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 so that means the series kept stretching on, well then I can't really find the sum because I don't know up to what number I'm finding the sum, or up to what term. So we always find the sum of a finite sequence. So if I say definitely there is a start and the end and an end, then we know that it's a finite sequence, and hence I can find the sum. So now here, because I know both the starting and the ending point, and you might say, well, don't we always know the starting and ending point? Well, I could just say 1, 2, 3, 4, 5, and the question could say, find the sum of the first 50 terms. So because the sequence starts at 1, you know the 50th term is going to be 50. But what if the sequence started at 17 and it asks you to find the sum of the first 231 terms? Well, you don't really know what that last term is. So then you don't have the starting and the ending, so you would have to use this formula. But now because I know both my starting and ending value, I could use the other formula, which says S sub n equals n over 2 times u sub 1 plus u sub n. So u sub 1 again is the first term, and u sub n is the last term. And if I were to substitute this, I would have s sub 100 equals n, which is 100 over 2, times my u sub 1 is 1, plus my u sub n is 100. Now, you might already have noticed that both these formulas give us pretty much the same result, because if I just solve what's inside the bracket here, I have 100 minus 1, which is 99, times 1, which is still going to be 99, plus 2. So 99 plus 2 is 101. And here I have 100 plus 1, which is 101. And outside the bracket, we have the same value. So these two are going to give us exactly the same result. So let's do a quick example. If I have the sequence 17, 7, -3, all the way up to -303. And I want to find the sum of this sequence. Well, going back to the equations we had in the previous slide, the first thing I see, or the first thing I ought to see, is that in both these equations, I have an n. Now, n stands for the number of terms, but given the current problem, I don't really know the number of terms. It starts at 17 and ends at -303, but I don't really know. This is the first term, this is the second term, this is the third term, but I don't know what number term this is. So in order for me to be able to solve this problem, I first need to find n. To do this, I'm going to use an arithmetic sequence formula, which is u sub n equals u sub 1 plus d times n minus 1. And I know u sub n because that's -303. I know u sub 1, which is 17, plus my common difference here, well, that's going to be 7 minus 17, and that has to be the same as -3 minus 7. And when I do that, I get my common difference to be -10. So that's, if I substitute that, it's going to be -10 times my n minus 1. I don't know what n is, so I can solve for n using this equation. So when I solve this equation, it says -303 equals 17. And then I have -10 times n, which is -10n. I have -10 times -1, which is +10. So I have -303 equals 17 plus 10, 27 minus 10n. So I get -10n. Well, if I subtract that on the other side, I get -330 equals minus 10n. The negatives cancel out, because if I divide by -10 on both sides, and then I'm left with n equals 33. This means there are 33 terms in the sequence. So now that we know what n is, I could choose to use either this equation or this equation. But because this one is simpler and we have all the needed information, I'm just going to use this one. So we have S sub n equals n over 2 times u sub 1 plus u sub n. That's going to be 33 over 2 times my u sub 1 is 17, plus my last term is -303. That simplifies to 33 times -143, and that gives me an answer of -4,719 for S sub n. Thank you, I hope this was useful, and see you in the next video.